All right. So today we're looking at volumes, surface area, and lateral area of both prisms and cylinders. We grouped these shapes together because their formulas are very similar. So a prism is when we have two of the same shapes that are basically across from each other. So we have rectangular prism, where it's rectangles across each other. Triangular prism, so a triangle across from each other. Another triangular prism, another rectangular prism. What do we call it if it's a square?
A cube.
A cube, good. So we're not limited to just triangles, rectangles, and squares. We could have any type of polygon. So this would be a hexagonal prism, so where our base is, so we refer to the shape that's the same as our base. So our bases are hexagons here. Our bases here are our triangles. For the rectangular prism, you kind of get to choose your base because they're all rectangles. So you can choose which rectangles you use. And for square, or for cube, all of them are the same squares. Okay, so our volume formula, and you once again want to commit this to memory, is area of your base times height. So when we're talking about base, again, our base are the two shapes that are congruent. The height is that distance between the bases. Distance between bases. So it's not always going to be drawn this way, where it has the triangle base sitting on the bottom and on top. Sometimes they do like to turn opposite side or just rotate it around. So keep in mind that our height is the distance between our bases, and our bases are the two shapes that are the same. All right. Then we have what's called lateral area and surface area. Does anyone know what surface area is?
Surface.
Johnny, explain to me surface area.
It's the total area of all of the sides of the 3D shape.
Good. So if I were to take the area of every side of my shape, and add together, that's my surface area. Let's talk about some technical terms. What do we call a side of a 3D shape? Base? Yes, who said that? Where'd that come from? Good work, Gus. So a side, if you would, is called a face. What do we call where the faces come together?
Edge.
Edge. And what do we call where the edges? A vertice or a corner. And then how great is this? It's like planes, you know, how many, or what's the intersection of two planes, so on and so forth. Okay, so anyway, our surface area is if I were to take the area of all of my edges, all of my faces and add them together. Now, our lateral area is if I were to simply add together the area of all the faces on the side. So we're basically just not including the areas of our bases. It's a little bit easier to recognize with our triangular prism. So surface area is I find the area of my front face, the back faces, the bottom faces, top face. My lateral area is if I just do the area of all the sides, or all the faces on the edge. So we don't include our two bases. Okay, so I'm just going to write this through here. Doesn't include area of bases. So although these are technically two different formulas, you don't really have to memorize them individually. You can either just think of your lateral area, memorize your lateral area, and then just add on the area of your bases, or memorize your surface area and just subtract your bases to get the lateral area. Okay. So again, bases are the two shapes that are congruent across each other. All right. So for number 1 here, we've got 8, 5, and 4. So our area of our base, we're just going to go ahead and establish that our bottom one here is our base. We'll use these rectangles as our bases. So area of our base, we use the capital B to denote that. So that would be 8 times 5. What do we get? 40. And its area of our base would be 40 meters squared. All right. So that's beneficial for us in being able to find our volume. The other thing that we need for volume is our height. So we've got our area of our base, that's our capital B. We now need our height. So my height is that distance between the bottom base and the top base there. What is that height? 4. So I have then my area of my base is 40, and my height is 4. So what's my volume going to be? 160 meters cubed. 160 meters cubed. Okay. Now if we take a look at our formula for lateral area, it's perimeter times height. I want you to discuss with your shoulder partner, why is it perimeter times height? Where does that formula come from? Think about what our lateral area is. And why is it perimeter times height? And that perimeter, that capital B, is again perimeter of the base. So if I were to add all these together.
That makes sense because it goes to the up.
But if it's not including the bases, how come you're doing
No, because it's from the corner and then it goes up. That's the lateral area. It's like, yeah, I get it. You can go like this. It's all your face. And then it's like this. Or like this. It's more like this. Shut up, Kate.
Alright, who can explain to the rest of the class why our formula is perimeter times height? Where does that come from? I heard lots of great discussions on there. Yes, I did, Danny. Danny. Where are you going? Stop. Why is it perimeter times height? Go ahead, Danny, do it.
Is it because the bottom thing in triangles is like instead of perimeter times bottom is height times perimeter?
I like that thinking. We'll go a little extension from there. Let's take a look at our lateral area. It's made up of this guy here. Well, let's take a look at what would be our area for this front-facing edge. 32. How'd you get that? What number? 8 times 4. Right. And then now let's take a look at this guy. What would we multiply for that?
5 times 4.
Okay. How about my one here in the back? 8 times 4. It's again just the same as that front. And then what about this guy over here?
I don't know.
5 times 4. What do we notice is in common about our areas for each piece?
They're all the same height.
They're all multiplied by 4. Good, so that's our height, right? So could I rewrite this then if I were to factor that 4 out? I would have 8 plus 5 plus 8 plus 5. Right, I'm just factoring out that 4, if I were to distribute it back out, I'd have 8 times 4, 5 times 4, 8 times 4, 5 times 4. Well, let's look at this number here, because this is our height. Let's look at this. Supposedly this is our perimeter. So our perimeter, we're talking about perimeter of the base. What is the perimeter of that base down there? How'd you get 26? And what are our sides, Johnny?
8.
We have 8, 5, this guy's also 8, and this guy's also 5. Isn't that just my perimeter? 8, 5, 8, 5, 8, 5, 8, 5, 8, 5, 8, 5. So it's because our edges, sorry, I keep saying edges, our faces, well really the edge of our faces, our faces are sitting on that base. So the length of that face is going to be just part of my perimeter. And they all have that same height, which is going to be the other length that we make. So that's where that comes from. Should you forget it, you can derive it. You don't have to, you can just memorize it. Okay. You're leaving me now? You knew it too. Okay, hold on. Let me get you. They're a little late. So can just look on Blackboard for the problem. Okay. So our lateral area, again, perimeter times height, or you can go ahead and find the area of each little one and add it together. Okay, so our perimeter, Johnny, what did you say it was? 26. And our height is 4. What does that give us? Well, we know 25 times 4. It's 25 times 4. 100. So what's 26 times 4? Okay, talk with those around you. What's 26 times 4?
200.
104. I got a little worried how many times I did not hear 104 before that. All right. What would be my units for lateral area?
Meters. Squared.
Is it meters or meters squared?
Squared, because it's area.
Squared because it's area. Alright, now TA is just standing for total area. Honestly, I normally will write it as SA for surface area. So our total surface area, we just simply take our lateral area and add to it 2 times our area of our bases, because we already have the area of the lateral sides. So now we just need the area of the top and the bottom, so our bases. And there's 2 of them, one on top and on bottom. Alright, so 2 times, and we already found that. So we've got 104 plus 80, what's that?
184.
184 meters
Cubes.
squared. Still area, still area. Okay. I didn't fill out the perimeter. What was our perimeter?
24.
What's our units for perimeter?
Meters.
Okay. So this is the general format, the general idea that we'll be doing. Now you'll notice on the front side here, it nicely sets up for you area of your base, volume, lateral area, and total surface area and perimeter. SFO does not do that. Our assessments won't do that, but this just kind of get us heading in that direction. Okay, let's do one that's not a rectangular prism. Let's go ahead and do number 2 here. Or is that, what is that? That's a 2. Okay. Alright, so again, our bases are triangles. So this is a triangular prism. And we want to do area of our base. What's the formula for area of a triangle? Good. 1/2 base times height. Now here, conveniently, this is a right triangle. So what do we use for our base and height in the right triangle? What do we call these thingies that are here? Legs. Good. So 1/2 times 6 times 8. What does that give us? 24. What are our units here? Inches. Good. The 2 quotes are inches. But we're talking about area, so this would be inches squared. Please do not put 24 inches squared. That is incorrect interpretation. That to me looks like 24 to the 11th power squared. So 24 to the 121st power, which would be a very large number. Alright, so what would be our perimeter of the base?
Oh, no.
Oh no, what, Johnny?
Oh, well.
It's actually not that bad.
It's actually easy.
So we do need to do Pythagorean theorem. If you remember your Pythagorean triples, a 3, 4, 5 triangle becomes a 6, 8, 10. Alright, so now we can do perimeter. What's our perimeter?
24.
Ooh, how convenient. 24 just inches for that one. Okay, so now volume. Volume is just area of your base times height. So you can think of volume this way. If I were to take that triangle and then do a bunch of those slices of that triangle and add them together, that would give me my volume, right? If I layer them all on top of each other, like stack a bunch of chips on top of each other. And so that height there would be all of them added together. I don't know if that makes any more sense or not, but our area of our base added together over and over and over again, which is our height. Okay, so it's our area of our base times our height. So our area of our base was 24. My height is 5. It's 24 times 5. 96?
No.
No way, that's not possible.
Good, 120. It should be over 100, right?
121.
4 times 5 is 20.
Because it's still alive.
Pretty sure.
20 times 5 is 100, 4 times 5 is 20.
1.
Okay, and that's inches cubed. All right, lateral area. So again, you can individually find the area of each base on the lateral sides and add them together, or just do perimeter times height. What is my perimeter again? 24. And my height was 5. So it's the same. Oh, how cool! It's almost the same. What's different? Oh, it's different units. So 120 inches square versus 120 inches cubed. Okay, in our total surface area, we just add together our lateral area and then 2 of our bases. So 2 times 24. What's 120 plus 48? 168 inches squared. Okay, questions with that? Pretty basic, pretty easy. Let's go and flip it over to the back side.
Whoa, give me 10.
Okay, so again, still the same concept, just different shapes now.
Can we get that? Can we get that out of the way?
What about this guy? Alright, fine, I'll do 10.
Yes.
Why would you want to do that?
Get it out of the way. We don't have to do some more.
Alright, so here this is not a normal type of 3D object, but we do know how to find the volume and air or surface area of the individual shapes. So it says find the volume and total surface area of the following prism. Now you want to be careful with your total surface area. We basically have the plus sign in front and back, and then all these sides here. Okay, let's take a look at our volume first. Now, this on top, what type of shape if I were to cut this off? What type of shape?
Rectangular prism.
Sorry, the top one.
It's a rectangular
It's a rectangular prism.
Is it a
Because
rectangular prism or a cube?
it's a rectangular, yeah, it's not all three, so it can't be cube because there's.
Alright, so this is 2, this is 2, this is 2. Good catch. Okay, now would you agree that the top one and the bottom one are the same? Okay, so I'm going to call this 1, 2. Okay, now for our middle chunk here, we could go ahead and section off into 3 sections, but would you guys be okay just doing it as a rectangular prism? So we don't have as many calculations to do. So I'm going to call this big eye here 3. Okay. So let's do our volume of what? That looks good. I'm just going to call it base of 1. Okay. So volume is again area of our base. I'm just drawing to finish this out. So area of our base, we can also look at it on the top here. What is our area of our base? Good. 3 times 2, which is 6. So area of our base times the height. What's my height? 3. Good. So my volume of cube what rectangular prism one would be 18. Did they give us units? No. So units. Okay. So then we know that the volume of the second one is also 18. Okay. Let's do the volume of the third one. So this is a rectangular prism. Let's see. Our base. Maybe we'll just go from up here. How much is this guy? 2. How much is this whole thing here?
9.
Good. 3 plus 3 plus 3, so 9 for this whole thing. Alright, so again, our volume is area of our base. So 2 times 9, which is 18. Times the height. And our height is 3. Ooh, what's 18 times 3?
54.
Units cubed. Okay, so our volume then, we just simply need to add these together. So 18, 18, and 54. I'm going to add those together to volume. What was that, 36 and 54? Yeah. Then 36, 54, 80, and then 10. Are you good, Becca? I just wrote T for total. total volume. It's because the doors, we have issues. Okay, so now let's our surface area. The surface area is a little bit more work, but again, we can just, I'm gonna just keep it with these 3 chunks. All right, so our surface area, what we need to be careful with for our top block here is that we have all of the sides except this bottom one, right? So we don't want to include that in. So you can either find the total surface area and then subtract away that base, but that is just one of our bases. So we can still do perimeter times height to get the lateral, and then just add on one of our bases rather than 2 of our bases, right? Because our total surface area formula is our lateral area plus 2 of our bases, or we just have one of our bases. Okay, so I'm going to do surface area. Yes.
I should just do this too, though, because you have the bottom one, it's the same as the top one. Or is that
Once we get the surface area for this block?
Yeah.
Yeah, yeah, then we'll have that same one for the bottom one.
But so do you have to say times the just one base, because then the bottom has one side gone as well?
So you could do the full cube and then just the lateral, I keep saying cube. You could do the full block and then just the lateral area if you wanted to. Where you basically take the base of this and put on your base of
Yeah.
Yeah, you could do that instead. Alright, so I'm going to go ahead and do surface area of our top block. So let's see, we need our lateral area. And lateral area, which is our perimeter times height. So my perimeter, we have that this is, how much again? 3. So 3 plus 2 plus 3 plus 2, how much is that? 10 for my perimeter. And what's my height? 3. Okay, so that was my lateral area, and then I'm going to add on just one of my bases. Area of my base here would be 6. 2 times 2, which is 6. Okay, I'm going to write it out. Okay. So my total surface area for my top block would be 30 plus 6, so 36 units squared. Now this is the same as the bottom block, because the bottom block once again has lateral and then one of my bases. So my surface area for that guy would also be 36. Okay, so now let's go ahead and find surface area for our rectangular, the big rectangular piece. Okay, do we have questions so far before we dive into the big chunk? What do you have questions? What's that?
36.
36 u squared per unit squared. Alright, so again, our formula here for our surface area. Now, once again, we want to be careful because we do not include this piece here or this piece here. So it's kind of up to you how you want to go about it. Find the total surface area and then subtract away those. Or find your lateral area and just add in these. I think I'm going to do lateral area and then just add in those. Okay, so once again, my lateral area is perimeter times height. So we've got to do perimeter. So let's see, this was, what was it, 9, 2, 9, 2. How much would that be? 9 plus 2 plus 9 plus 2, 22. That's my perimeter. And my height is 3. So that's my lateral area. And then I'm going to go ahead and, this is the same thing 4 times. So I'm going to do 4 times whatever we get for this area. What was this like? 3. And what was this? 2. So 3 times 2. Alright, so now we just add that together. What was that? 66 plus 24. How much is that? 90. So 90 is 90 units squared. So then my total surface area for the whole hunkin' thing is 36 plus 36 plus 90. So 72 plus 90. How much would that be? 162 units. So quite a bit of work, but it's really just plugging and chugging, plugging and chugging, plugging and chugging. That's what you'll find for this unit, is it's really just plug and chug into a lot of formulas. questions with that? Alright. I'm gonna pause there. Let's take a look at our cylinders. Cylinders. You thought it couldn't get any better than this. I like the cylinders better, actually.
Great, conference is back. Are you saying I feel concerned? Hey, that contact. We're gonna kiss it out.
Is there anyone that did not get the cylinders worksheet? Everyone got it? Alright. So, what I love about cylinders is it's really just the same formula as it is for our rectangular, or for our prisms. Our prisms, our volume was area of the base times height. Our lateral area was perimeter times height. Surface area is just our lateral plus 2 bases. When we take a look at our cylinders, our volume is still area of the base times height. Our lateral area before was perimeter times height. Well, our perimeter of a circle is just simply circumference. So that's why it's circumference times height. That's still the same idea, that perimeter times height. And then once again, our surface area is just our lateral plus 2 times height. So it's the same formulas for both prisms and cylinders. So now we get to have some pies. Okay. Let's go ahead. I don't know that I had a favorite. Let's just do number 1. Alright, they give us our height is 15 and our radius is 10. So area of the base. What is the area formula for our base is a circle? What's the area formula for a circle? Pi r squared. So what's our area of our base? 100 pi. And what are our units? Inches squared. Alright. What's our formula for circumference? 2 pi r. Alright, so 2 times 10, so 20 pi. What's my units? Alright, so volume is once again area of the base times height. And guys, you can't forget these formulas. We use them in calculus. You can't forget them. They don't give them the formulas. And when they looked at me and I was like, well, what's the area of a cylinder? And they looked at me cross-eyed. Not good. Don't forget them. Okay, so volume is again area of our base times height. So our area of the base is 100 pi. And our height is 15. So what's our volume? 1,500 pi inches cubed. Alright, lateral area. Again, perimeter times height. So for our cylinder, perimeter is just your circumference. So circumference times height. 20 pi times my height of 15. Ooh, what's 20 times 15?
300.
Okay, that was nice. I was hoping for a little more of a delay. Inches squared. And then total surface area again. So that was our lateral area. If I were to unroll that cylinder, it's kind of like, this is not the best example. So you know those crescent rolls where you have to like pop, you like peel off the wrapper and then you pop it and you unroll it? Well, it is a square, but it unrolls as a spiral, so that wasn't a great example. It unrolls as a parallelogram. Anyway, so if it didn't unroll like a spiral and you just cut a line across it and then unrolled it, that would be your lateral area. But now we want to add on the ends. I have a side skirt, but let me finish this problem before I tell you the side skirt. So our total surface area, we just take our lateral area. And we've got 2 bases here, so we want to add the area of both bases. So 2 times 100. 2 times 100 pi. So what's our total surface area? 500 pi, and what's our unit? Inches. Okay. So same formulas, just now instead of perimeter, it's the same thing. Okay, so here's my side story. I used to work at a grocery store during the summers of college, and there was one time, so summers and Thanksgiving, Christmas break. There was one time during Thanksgiving break that a lady was shopping and her crescent roll thing, and just it did not hit anyone, but it was a little alarming. And that's my story. Okay, so let's take a look at, is there anything weird on the back? Oh! Don't go to the back yet. Okay, it's fine if you went to the back. Just look up here for 3 and 6. All I did was just turn the radius on it, or the cylinder on its side. The height is still the distance between our circles here. It's not this guy. It's still the height between our circles. Remember, the height is the distance between our bases. Wait, let's go back. What's the weird one?
9 and 10.
9 and 10.
But 10 is worse. Let's do that.
10's worse? All right, let's do 10. Yes.
Will they ever show you the height on the outside?
It's possible. Yeah.
So if they show you like,
So they might show the height, they would do this.
okay.
Okay, so we said 10 was worse?
Because you want to make area a square and it's a circle.
It's not a square.
Okay. So it says find the volume of the hollowed out object. What does that mean if something's hollowed out?
There's nothing in that
Right. They took that middle and took it out. Think of a hollow tree, there's nothing in the center of the tree. Alright, so they've taken the middle and pulled that out, and we're left with this beautiful shape here. Alright, so they've given us the end view. They told us that our radius of the circle is 2 inches. This looks to be a square on the end, so 5 by 5. And then our length here is 20. Okay, so find the volume of the hollowed out object. What do we do? What do we have to do? Let's see.
Rectangular prism. Find the volume of the cylinder, then minus the cylinder volume from the rectangular prism.
Good. Very good. That's exactly it. Find our volume of the whole shape, the rectangular prism. And then we want to subtract away from there that cylinder that was pulled out. Okay, so you can imagine if you had a rectangular prism of Jell-O, and then you took a straw, put it in, and slurped that out. That's what we've got here. All right. I've been trying to come up with an example for years, and I finally got one. Okay. There's probably more realistic examples like concrete barriers and whatnot, but I like the Jell-O one. So we need to do volume of our rectangular prism.
It's just a really long version.
What's that?
It's a really long version.
Yes. I like that. Alright, so again, volume is area of the base times height. Right, so volume is area of the base times height. And again, you've got to commit these formulas to memory. Now, it's up to you what you want to choose as your base. I'm going to go ahead and just choose what's on the bottom as my base. Okay, so area of my base, 20 times 5, so 100. My height, 5. So my volume of the rectangular prism, I'm going to say, would be 500 inches cubed. Okay, and we want to subtract away from there the volume of our cylinder. Okay, so the same formula, area of our base. Our base, though, for a cylinder is circle. And area of a circle is pi r squared. What's my radius again? 2. So 4 pi. Times my height. What's my height of this cylinder? Good, 20. Okay, so what does that become? So this is my base, and then my length of it, if you want to think of that. Okay, what was our volume of our cylinder? 80 pi inches cubed. Okay, so our volume of the hollowed out object, would be the whole thing, 500, minus the Jell-O we slurped out, 5 inches cubed. Can we combine 585? Ooh. So actually, whenever working with pi, it's preferable to leave it as pi because that's the exact answer rather than the nastiness. But if I told you to give me the decimal, and I gave you calculator, yes, no.
So you can't break minus the only number with the number with the pi.
Say that again.
So you can't break minus a normal number with the number with the pi.
Correct. Yeah, because I have, it's kind of like variables of x and y. I have 80 pi's. 500 is not in terms of pi, so they're not compatible units.
What about multiplication?
Yeah. So then I would, let's say it was like 20 times 5 pi. I have 20 groups of 5 pi, so 20 times 7 is 100 groups of pi. Okay, find the lateral area of the outside. All right, so lateral area, again, we are going to include our bases here. So our lateral area, we're just doing this plus this all the way around. So lateral area is perimeter times height. All right, so using this as our base, we need the perimeter for that. What's our perimeter? This guy. Good. And then my height, again, that's between your bases here. The height is between your bases, so my height would be 20. What's 20 times 20? 400, and this is inches. All right, lateral area of the inside. Ooh, the lateral area is slurped out jello. So what shape are we talking about the lateral area?
Cylinder.
The cylinder, okay. So it's still the same formula, but for cylinder, our perimeter is really circumference. Okay, so our lateral area is circumference. Our radius was 2, so what's our circumference?
2, 4, 5.
Good, 4 pi. And what is my height again? 20. Again, height is the distance between your bases. All right, so we have our lateral area of the slurped out area is 85 inches squared. A very rough estimate about how much is 85. 240. Good. 3 times the 80. Just 3 times 80. Just rough. Right? Times 3.14. Nothing too crazy. You looked at him like he was crazy.
Oh, yeah.
So, again, rough estimate. Pi is 3.14, so just 80 times 340. So it's a little more than half of that guy, which is interesting.
Like 250-ish.
250-ish. I like that better. Okay. Questions? What we've done here?
For the lateral area of the outside, why is it 355?
So our bases is this guy, and our so our perimeter then is going to be 5 plus 5 plus 5 plus 5. So that's our first point. And then our height is the distance between the bases, and that's that 20 there. Other questions with this one? Okay. So again, just same formulas. They just like to throw different types of shapes at you, and what you have to use these. All right.